get now to an example of sine 80. Since on the previous videos I've done how we can derive the simplified formulas of Laplace transform of sine 80, of which we got them to be a all over s plus s squared plus a squared. Now this is now our example whereby you can be told find the Laplace transform of a function f of t is equal to sine 80. We understand using the first principle, we understand that the Laplace transform of a function f of t is equals to our integral exponential negative st multiplied by a function f of t with respect to dt. But now from here, we understand that in our next step, whenever we have a function f of t, we are going to replace with sine 80. And by doing that, we are going to have our integral exponential negative st of a function f of t, which is equals to sine 40, and our integration is with respect to dt. Now from here we find a way by which we can change the sign into an exponential, and the way by which we can change the sign into an exponential, we say that we are going to have exponential j40 is equals to cos 40 we add to j sine 40. This side stands to be for the imaginary and this side stands to be for the real. So since we are going to use the imaginary side, we are going to take I exponential 40 is equals to I sine 40, to mean that where we have sine 40, we are going to replace with I exponential j40. Since that we are going to take the I, since sine stands to be on the imaginary part, and by doing that now we are going to have our integral with respect to our limits exponential negative st multiplied by imaginary exponential j40, and our integration is with respect to dt. Now from here we understand that we are going to factor out I since it is not a term of dt. So this one is a constant, and by using the laws of logarithm we understand that when the bases are equal, when the bases are the same, we take one of the bases. Since it is a multiplication, we take one of the bases and add the powers. By doing that, we are going to have I as our constant, our integration with respect to our limits exponential negative st we add to j40, and our integration is with respect to dt. Now from here we are going to have, we are going to factor out our term of t here, and by factoring out our term of t we are going to have is equals to exponential. Here we are going to have j for t. Sorry, we add 2 we are going to have that. Now, let us do our integration, and by doing our integration, we are going to have I. When we do our integration here, we are going to have exponential over and our integration was with respect to our limits. Now, after doing your integration, we are going to factor out the denominator since it does not contain a term of t, and then we insert our limits. By doing that, we are going to have I over j4 minus s into exponential j4 minus s t. Our integration was with respect to our limits. Now let us insert our limits here. We are going to have j4 minus s. When we insert our limits, now we are going to have exponential j4 minus s power infinity minus exponential j4 minus s raised power 0. Now, anything raised power infinity, we understand is equals to 0. When we take 0, we multiply by what we have within our bracket, we are going to have 0. Anything raised power 0 is equals to negative, is equals to 1. So we are going to have negative 1 multiplied by j4 minus s. Now from here, this negative is going to affect the denominator. We are going to have I over, here we are going to have s minus j for us as our answer now up to that point. But we need to separate the real and the imaginary. And by separation of the real and the imaginary, we are going to get we are going to multiply the denominator by its conjugate. We are going to do now at the rationalization. And by rationalization of the denominator, we are going to have so by rationalization, we are going to take the conjugate of the denominator, whereby now this sign is now going to change to be a positive over s. We say that we add to j4. Now let us work out what we have here. And by working out this one, we are going to have s. We add to j4 over. Here we are going to have s squared. And this one we are going to have, we add 2. sorry, this one when we multiply by this one, we are going to have s squared. When we multiply that, we are going to add 2j for s. We subtract from this one multiply by this one, we are going to have j for s. This one multiplied by this one, we are going to have negative of j4 squared. This one is a positive, this one is a negative, to mean that it is going to cancel out, and we are going to have as we add to j 4 over s squared subtract from j squared 16. Now here we understand that from the complex numbers j squared is equals to a negative of 1. That one means that when we take j squared here, we are going to have a negative 1. Negative multiplied by a negative is going to be a positive. And here we are going to have now s squared we add to 16. Now from here we can separate the real and the imaginary side, and by separation of the real and the imaginary we are going to have now s over s squared we add to 16, we add to j power 4 of, here we add to s squared, we add to 16. Now from here we've separated the real and the imaginary. We come and, since we are working for the imaginary, we come and now say, hence we take the imaginary part. And by taking the imaginary part, we are going to have 4 over s squared we add to 16. And this is now equals to the Laplace transform of sine for 40. This is how you go about the Laplace transform of sine 40. Let us now use our alternative method in solving the Laplace transform of sine 40 using the first principle. So we understand by the first principle, the Laplace transform of a function f of t is equals to our integral with respect to our limits 0 up to infinity negative st of a function f of t. Our integration is with respect to dt. So from here we are going to replace our function f of t with sine 40, and we are going to have our integration with respect to our limits exponential negative st. Our function f of t is equals to sine 40, and our integration is with respect to dt. Now from here we understand that exponential ax sine bx is equals to exponential ax over a squared plus b squared into a sine bx subtract from b cos bx. We are going to relate this formula with what we have here. And by relating the two, we have an integral with respect to our limits of an exponential negative st sine 4 t is equals to, here on the numerator, here we are going to have exponential at is from here. So in our numerator here, we are going to have exponential negative st over a. Our a is equals to this one, to mean that a will be now negative s squared. We add to b is equals to 4 here. So here we are going to have 4 squared into a. Our term of a will be negative s sine bx is equals to 4a 4t, sorry. We subtract from b. Our b is equals to 4, and we are going to have cos b, sorry, cos 4t. And our integration was with respect to our limits 0 up to infinity. Now let us factor out our denominator, since it does not contain a term of t which will be affected by the limit. Now we are going to have an integral exponential negative st sine 4t with respect to dt will be equals to, here we are going to have 1 over a squared, we add to 4 squared into exponential negative st into negative s sine 4t. We subtract from 4 cos 4t, and our integration was with respect to our limits. Now we are going to solve what we have here by inserting our upper limit and the lower limit. By inserting our upper limit and the lower limit, we are going to have 1 over s squared, we add to 4 squared, which will be equals to 16 into, here we are going to have exponential negative s with respect to the upper limit into negative s sine 4 of infinity minus 4 cos 4 infinity. We subtract from the lower limit. Our lower limit, we are going to have exponential negative s of 0 into negative sine negative s sine 4 of 0. We subtract from 4 cos 4 of 0. Now, after inserting our upper limit with our lower limit, this is what we are going to have. Here, we can simplify what we have within the bracket and say 1 over s squared plus 16 into anything that's power infinity is equals to 0, and we are going to have 0 multiplied by what we have here is going to be 0. We subtract from here, we are going to have 1 into sine 4 multiplied by this one is going to be a 0. So sine 0 is equals to 0. So we are going to have 0. We subtract from 4. Cos of 0 is equals to 1. When we simplify what we have within this bracket, we are going to have negative 1 multiplied by negative 4, which is going to be 4. And by doing that, we are going to have now 1 over s squared we add to 16 multiplied by 4. So 4 we are going to multiply by 1, and our answer we are going to have as 4 over s squared we add to 16. This is now the Laplace transform of sine 40 using the first principle formula.